So good afternoon everyone to my YouTube channel Math Avatarm. So hope you all are good and you are doing well. So today we are going to see another question on uniform convergence of function. Function, a sequence of functions given in three subintervals, and ultimately it is defined on a closed interval 0, 1. So four options are given. First option is does not converge pointwise on closed interval 0, 1. Second option is Fn converges uniformly on closed interval 0, 1. And third option is Fn does not converge uniformly on closed interval 0, 1. And fourth option is none of the above. Okay. So we'll see this question and we'll solve it finally. Okay. So to solve this question, we need a statement of a theorem which I have taught in lecture number 1. In uniform convergence of functions lecture number 3, I have taught this theorem. Okay, so I'm writing the statement of theorem. We will use that statement. Okay, what is the let Fn close interval 0 to 1 AB remain integrable. Okay, remain integrable for each n belongs to n, and Fn converging to F uniformly on closed interval AB. Okay, then F is also remain integrable, and then F is also remain integrable. Moreover, we have this sequence, the sequence of integral. This sequence a to b Fn dx tends to a to b f dx. Okay, so we will write this statement in a contrapositive way. How? In other words, if Fn f0 to ab to b to r close interval ab to r remain integrable functions such that this integral do not converge to this integral, then what can you say? Then this Fn cannot converge to F uniformly. Okay, so we will use this result. Okay, now you see function is given. Now come back to solution of given question. Okay, so what is function given? Function is Fn(x) is equal to, it is n square x if you are taking your x in this range. Okay, and this is n square x plus nx if you are taking x in this range, and this is 0 if you are taking okay. Now you see that fn is equal to fn is fn in this interval is n square x. So fn is, because this is a polynomial, so fn is Riemann integrable on, okay, 0 to 1 by n this interval. Okay, because this is nothing but n square x function. Okay. Now what about this interval? You can take, because you x, we are only accept n is equal, x is equal to n. This is polynomial function. So function is fn is also Riemann integrable on this interval. Now similarly, because except one point it is zero function, it is Riemann integrable. Okay, because this is zero function. On, okay, so but closed interval 0 1 is union of these sub intervals. Okay, so what does it mean? It means fn is each fn is Riemann integrable on 0 1. Now what, where it converges point wise, fn, where fn converges point wise, let's see. So when x is equal to 0, what is fn? Fn 0, because when x is equal to 0, this x will lie in this range 0 to 1 by n closed interval, this range, because x is 0. So we'll take n square x function. So let's take n square x function you are taking. So x is 0, so this is 0. This will converge to, because this is a, for each n it is 0. It means it is a constant sequence 0, so it will converge to 0. That is f0. Okay. Suppose x is in this range, because we have only interval 0 1, close interval 0. Either x will be 0, x will be non-zero in this range. So either x is 0 or x will be in this range. Okay. So by r, because x is non-zero, by rk median, x is non-zero and it is positive. By rk median property of real numbers, what we have, Archimedean property of real numbers, there exists capital N belongs to N such that 2 is less than N times X, because X is not positive. So it means 2 upon N is less than X. Okay. Okay. Now this implies, so if we take any N greater than equal to N, then 2 upon N will be less than equal to 2 upon N. But 2 upon N is less than X. So this implies this. Okay. So what does it mean? 2 upon N less than X, but X is always less than equal to 1. So we have this one. When we have this one, where X lies in this range. And for this range, my Fn is defined 0. So Fn is 0. So for such X, Fn is 0. So we have Fn X is 0 for all X greater N greater than equal to N. Okay. So where it will converge? This implies Fn X because this will converge to 0. That is my fx for all. So finally, what we got, fx is equal to 0 for all x belongs to closed interval 0. So pointwise limit is 0 function. Okay. So what is this? So f is Riemann integrable. So what is the integration 0 to 1 f dx? Because this is 0 function, the integral will be 0. Okay. Now what about fn integral? Now next 0 to 1 fn dx. We can break it in 3 subintervals. Okay. But in this subinterval, fn is 0. 0. Okay. In first subinterval, it is n square x dx. N square, sorry. And in second subinterval, it is nothing but minus n square plus nx dx. Okay. So solve it. This is, what is this? This is n square will come out and its integration is x square by 2. And what is this? Minus n square x square by 2 plus n x square by 2, 1 by n, 2 by n, and this is 0 integration because function is 0 here. So what is the limit here? So after solving it, what you will get? When you put 0, it will give you 0 and 1 upon n square, but n square is outside. So you will get 1 by 2 here. And what about when you put 2 by n? You will get here minus 2 and this is 2 upon n. Okay. Minus this is minus 1 by 2 plus 1 upon 2n. Okay. So you have 0 to 1 fn dx. Okay. If you tends when n tending to infinity, this will be 0, this will be 0. Finally, where it will converge? 1 by 2 plus minus 1 by 2 minus 1 by 2. So what is this? 1 by 2 minus 2 plus 1 by 2. So what is this? This is 1 minus 2, that is minus 1. So this means 0 to 1 fn dx, that is, so this integration tends to minus 1. And we already checked that this integration is 0. So minus 1 cannot equal to 0. So what does it mean? It means this implies 0 to 1 fn dx does not tends to 0 1 fx dx. So what does it mean? Fn is Riemann integral, f is Riemann integrable. Integration do not converge. By contrapositive way, we have already explained. In other words, this implies Fn do not converge to f uniformly on closed interval 0 1. Okay, so Fn do not converge uniformly to 0 1. So let's now go back to options of questions. So option number 1 is Fn does not converge pointwise on 0 1. But we have checked its pointwise limit is 0. It converges to pointwise, but is given it does not converge. So option number 1 is not correct. Fn converges uniformly. Fn do not converge uniformly. We have already checked. So this option is also not correct. Fn does not converge uniformly on 0 1. Yes, this is correct. And fourth option is none of the above. So it is obviously not correct because we have C, third option, does not converge uniformly. That is correct. So thank you very much for today's question. This is very important question. Like, share, like, comment, share, and subscribe my YouTube channel. And if you have any problem related to this question, you can comment on my YouTube channel. Thank you very much for today's question. Thank you very much.